osmosis and osmotic pressure. These two are very important. We hear the osmotic pressure. Osmotic pressure is the fourth very important colligative property. To understand the osmotic pressure, first we have to understand the osmosis and also the semi-permeable membrane. Let us understand each of them. Semi-permeable membrane. It is a membrane which allows only solvent molecules to pass through it and not solute molecules. It is a one type of a membrane. It is a membrane which allows only solvent. It allows only solvent particles, not the solute particles. Such type of membrane is called as semi-permeable membrane. Example for semi-permeable membrane is protoplasm of plant cell or Parkman membrane, etc. The first very important to understand is osmosis. What is osmosis? Osmosis is the process where the movement of solvent molecules, it is the movement of solvent molecules through a semi-permeable membrane, through a SM I have written short form, that is semi-permeable membrane, from solvent to solution. Okay, from solvent to solution. What is osmosis? Osmosis is the movement of solvent molecules through the semi-permeable membrane from where? From solvent to solution. Such type of a process is called as osmosis. Let us understand this osmosis in little detail. Osmosis. If a pure solvent and solution are separated by a semi-permeable membrane, there will be net flow of solvent molecules through the membrane into the solution. Okay. If a pure solvent and a solution, you separate it by a semi-permeable membrane, then there will be net flow of solvent molecules through the membrane into the solution. Obviously, the same definition I have explained. Here, consider the solvent particles as water and solute as salt, and salt and water together make a solution. These solvent particles and water and the solution are together separated by a semi-permeable membrane. There will be the net flow of solvent molecules through this membrane from solvent to solution. Obviously, this compulsorily osmosis must be flowing from solvent to solution. Similarly, when a dilute solution and a concentrated solution are separated by a semi-permeable membrane, there will be net flow of solvent molecules from dilute solution to concentrated solution. Similarly, when you take the concentrated solution and dilute solution these solutions are separated by a semi-permeable membrane, then there will be flow of solvent molecules from only dilute solution to the concentrated solution. This phenomena of solvent molecules through the semi-permeable membrane is known as osmosis. This type of process where the movement of solvent molecules with the help of a semi-permeable membrane from solvent to solution is called as osmosis. Osmosis is defined as the movement of solvent molecules through a semi-permeable membrane from solvent to solution. Osmosis is a very simple process where the movement of solvent molecules with the help of a semi-permeable membrane from solvent to solution. It is very easy. Pressure. This osmotic pressure is mainly denoted by the symbol pi. Okay. Firstly, we should understand what is osmotic pressure and why we have to study osmotic pressure in this chapter. Because obviously we are studying this osmotic pressure as it is the fourth important colligative property. What is colligative property? Colligative property is the property which depends only on the number of solute particles. It depends on number of solute particles in the solution. Let us understand how this osmotic pressure depends and what is osmotic pressure and its working system. of solvent into the solution through the semi-permeable membrane can be stopped by applying pressure on the solution. We know that first of all we should know what osmosis. Okay, osmosis is the movement of solvent molecules through a semi-permeable membrane from solvent to solution. Okay, when you apply pressure on the solution, the movement of solvent molecules from solvent to solution can be stopped. Such type of pressure is called as osmotic pressure. See, the flow of solvent into the solution through the semi-permeable membrane can be stopped by applying pressure on the solution. Consider a vessel divided into two compartments by semi-permeable membrane. Okay, this is a vessel containing two compartments, 1 and 2. It is separated by a semi-permeable membrane. This is a semi-permeable membrane which is denoted by SPM. Okay. One of the compartment is fitted with a narrow tube. This is a compartment which is fitted with a narrow tube. Look here. It is fitted with a narrow tube. It consists of mainly solvent. If you are not visible in this diagram, take one NCERT textbook, that is chemistry, and look at there. Okay. One of the compartment is fitted with this is a narrow tube which is fitted and filled with the solvent. This is the part where solvent is filled. And the other compartment fitted with the piston. This is a compartment where piston is fitted and the solution is taken in this compartment. This compartment mainly consists of solution and this compartment mainly consists of solvent. It is a very simple process. Osmotic pressure is a very simple process where you do not allow the movement of solvent molecules through a semi-permeable membrane from solvent to solution. Here what happens, the flow of solvent into the solution through the semi-permeable membrane will be stopped. How it will be stopped? By applying the pressure. This type of pressure is called as osmotic pressure. This is solution and this is solvent. Here solvent is fitted with the narrow tube and the solution is fitted with the piston. Here obviously we have here solution and here we have solvent and we also have the semi-permeable membrane. Obviously when we have these three things, there will be osmosis. Here osmosis will be taking place. When the osmosis takes place, there will be net flow of solvent. Into the solution. Solvent will be going into solution with the help of a semi-permeable membrane. Simple. Here what happens, when these solvent particles will flow into the solution, there will be pressure increasing here. Why here pressure increases? Because there will be the more water here, more solvent particles will be coming. It will give rise to the piston. Piston will grow up, means piston will tend to move upwards. As the solvent will be going into the solution, then the solvent, take for example tank and your anything bucket. When you fill the bucket with water, and put it into the tank, obviously tank will rise with the water. Similarly here the solution will be rising with the solvent, means when it will be rising with the solvent, obviously then piston will also tend to move upwards. Right? Simple process. The piston will tend to move upwards and level. Here what happens? Here the solvent get decreased. It means here this narrow tube will be coming in a decreased way. It will go down step by step. Similarly, as it go up, it will be going down. Simple. Okay. When you apply external pressure on this piston, what we denote the osmotic pressure? We denote osmotic pressure by this symbol, osmotic pressure. When you apply osmotic pressure here, when the osmotic pressure is applied, the entry of the solvent into the solution can be stopped. Obviously, when you push this piston down and down. The solvent molecules cannot be entered here, and there will be overflow from this tank. Obviously, it is a simple process. This pressure which is applied on the surface of the solution, the pressure which is applied on the surface of the solution is called as osmotic pressure. Osmotic pressure is a simple process where the external pressure is applied here on the solution, to prevent what? To prevent the osmosis. It is a process mainly which is for to prevent the osmosis of the solvent, of where the solvent moves to solution. It mainly prevents the movement of solvent into solution through semi-permeable membrane by applying the external pressure. This type of pressure is called as what? Osmotic pressure. Let us understand with the help of a notes. Due to osmosis, there is a tendency for the net flow of solvent into the solution through a semi-permeable membrane. As I told you, osmosis will be taking place when semi-permeable membrane, solvent and solution is present. So there will be flow of solvent into the solution through this membrane. As a result, the piston will tend to move upwards and the level of narrow tube will fall. Okay, the piston will rise up and this narrow tube will fall, means it will come down, right? If some external pressure is applied on the piston, the entry of solvent into the solution can be stopped. Obviously, when you apply pressure on the solution, that is pi amount of pressure on the solution, it will tend to stop. This pressure which is applied on the surface of the solution is called as osmotic pressure. The pressure which is applied above, such pressure is called as osmotic pressure. The perfect definition for osmotic pressure is the external pressure that has to be applied on the solution to prevent the osmosis of the solvent into it through a semi-permeable membrane. This definition means it is the process which prevents the movement of solvent molecules into the solution through the semi-permeable membrane by applying the external pressure. Pressure is a colligative property. What is colligative property? Colligative property is a property which depends on the number of solute particles. Here, osmotic pressure is a colligative property as it depends on the number of solute particles. For dilute solutions, it has been found experimentally that osmotic pressure is directly proportional to molarity, say, of the solution at a given temperature T. Thus, here what happens? This osmotic pressure, which is denoted by pi, is directly proportional to the molarity. So pi is equal to CRT. Pi is equal to CRT, where C is equal to N2 by V. C is equal to N2 by V. Number of moles of solute, N2 is the number of moles of solute and V is the volume of solution. Here R is a gas constant and T is a temperature. Okay, R is a gas constant, C is equal to N2 by V, where N2 is the moles of solute, V is a volume of solution in liters, and when you put these values in this equation, pi is equal to N2 by V RT. When you take V here above, pi V is equal to N2 RT. This equation is called as Van 't Hoff equation for dilute solution. We will understand Van 't Hoff's equation in abnormal molar masses. This equation is called as Van 't Hoff equation for dilute solutions. Okay, if W2 grams of solute of molar mass M2 is present in the solution, what is N2? We know that N2 is the number of moles. Its formula is W2 by M2. I have told you already in the second class. N2 is equal to W2 by M2. When you put this value in this equation N2, you will get the value. That is pi V is equal to W2 by M2 into R2. Okay, by this equation, when you take M2, M2 is equal to W2 RT by pi V, you will get to find the molar mass of the solute. Knowing the quantities W2, what is W2? That is the grams of solute of molar mass, temperature T, pi osmotic pressure, V volume. We can calculate the molar mass of the solute easily.